Cambridge IGCSE, Paper 1, October-November 2014. Number 1. Diagram 1 shows measuring cylinder containing water. 5 individual steel balls are now lowered into the measuring cylinder. Diagram 2 shows the new water level in the cylinder. What is the volume of each steel ball? Suppose that the volume of the steel ball is V. Initially the volume of water is V1 is equal to 40. The volume of water, which means 40 plus volume of the 5 balls, so V is the volume of one ball, so this is 40 plus 5V is equal to 70. 40 the volume of water, 5V the 5 balls, since each one is V, and the total is 70. So 5V is equal to 70 minus 40. 5V is equal to 30, and so V is equal to 30 over 5 equals 6 centimeters cubed. So the answer is A. Number 2. The graph shows how the speed of a car changes with time. Between which two times is the car stationary? Stationary means at rest, so the speed is equal to 0, which is in this interval between x and y. So D. Number 3. A man stands by a railway track. A train traveling at 40 meters per second takes 2 seconds to pass a man. What's the length of the train? Length is equal V times t, speed 40 multiplied by the time taking to pass from beginning to end, which is the length of the train, so equal 80 meters. D. 4. The mass of an astronaut is 70 kilograms on Moon. What's the mass on Earth? We all know that mass is constant everywhere, so it's the same, and the answer is B. Number 5. The weight of an object is found using the balance shown in the diagram. The object is put in the left hand pan and various weights are put in the right hand pan. These are the results. What's the best estimate of the weight of the object? Putting a total weight of 0.1 plus 0.1 plus 0.5 plus 0.2 newtons, which is equal to 0.27 newtons as total weight. Balance tips down slightly to the left hand side. So this means that this weight is less than the weight of the object. That's why it will tip to the left on the left hand side, so the weight of the object will be greater than this value. Now putting 0.2 plus 0.1 plus 0.01, which means 0.31, it will tip slightly to the right hand side. So now this is more than W less than 0.31, so it's between these two values, which is 0.29, and so the correct answer is B. Number 6. The diagram shows the dimensions of the rectangular block of mass M. P length, Q width, and R height. Which expression is used to calculate the density of the metal? Density is equal to mass divided by volume. Mass of this block is M, and the volume is the product of length, width, and height. So the answer is D, M divided by P Q R. Number 7. In which situation is no resultant force needed? No resultant force means F, which is equal to MA, is equal to 0. Part A, a car changing direction at a steady speed. B, moving in straight line and steady speed. C, car slowing down. D, car speeding up. In order to have F is equal to 0, so A also should be equal to 0. When A is equal to 0, this means that velocity is constant velocity. And when we say velocity, it means speed or magnitude of the velocity plus direction. When we say car is slowing down, means acceleration is negative and not 0, so this is not the case. Speeding up, A positive, also not the case. Steady speed, but changing direction. So speed is constant, but velocity is not constant. Only in B, straight line, so direction is not changing, and speed as well is not changing, which is the case. So the answer is B. Number 8. Which properties of a body can be changed by applying a force to the body? Mass, motion, shape. Mass, motion, but not shape. Mass, shape, but not motion. Motion, shape, but not mass. Of course, mass is always fixed and can never be changed. So whenever we see mass, we reject the answer. Force can cause a change of motion and the shape, but not the mass. So the answer is D. Number 9. The list contains 3 energy resources PQR. P. Geothermal energy from hot rocks. Q. Nuclear fission in reactors. And R. Sunlight on solar panels. Which of these resources is renewable? Geothermal. Nuclear fission is non-renewable. And sunlight also renewable. So P and R. And the answer is B. Question number 10. The diagram shows 3 different containers, J, K, and L. Each container contains water at the same depth. Which statement about the pressure of the water on the base of each container is correct? The water pressure is greatest in container J, K, L, or it's the same. Of course it's the same because pressure in liquid is equal density times gravity times height. Since all of them contain water, so same density and same height, and of course gravity is the same, so the same pressure for all of them. 11. Which movement will require the greatest amount of work to be done? We know that work is equal force multiplied by distance, so greatest amount of work means greatest force and greatest distance to give us the greatest work. So the answer should be between these two, with a bigger force and the bigger distance, which is D. Number 12. A water manometer is connected to a gas supply. There is a gas leak and the pressure of the gas supply falls. What happens to the water level at P and what happens to the water level at Q? When the gas leak and the gas pressure fall, pressing here will decrease, which means that the water here will rise upwards, and of course at Q it will fall down. Water level at P rises, Q falls, so the answer is C. 13. The diagram shows a beaker of water. 4 molecules are labeled. The relative amount of energy of each molecule is shown. Which molecule is most likely to escape from the liquid? To escape, it should be at the surface with the highest energy. So it's A or B, and we choose A because it has higher energy. Number 14. Some gas is trapped in a container of fixed volume. The temperature of the gas increases. Which graph shows how the pressure of the gas changes with temperature? Pressure is actually directly proportional to temperature. So when you increase the temperature, the pressure should increase with it, which is only in part D. Number 15. Which points are the fixed points of the liquid in glass thermometer shown? Of course, the fixed points are the melting point of ice or freezing point of water and the boiling point of water, which means 0 and 100 degrees Celsius. So the answer is C. 16. Equal masses of two different liquids are put into identical beakers. Liquid 1 is heated for 100 seconds. Liquid 2 is heated for 200 seconds by heaters of the same power. The temperature of both liquids increases by the same amount. Which statement is correct? Both liquids receive the same amount of energy? Of course not, since E energy is equal power multiplied by time, and the time is changing, even though the power is the same. Liquid 1 receives more energy than liquid 2. Actually, energy is directly proportional to temperature, as we can see. So the one who was heated for a longer time means that he receives more energy. Both have the same thermal capacity? Of course not, because they have the same increase but with different energies. The thermal capacity of liquid 1 is less than the thermal capacity of liquid 2. Liquid 1 rises faster than liquid 2 since it increases by the same amount in less duration, so it can be heated quickly and it can cool down quickly, unlike liquid 2, which will be slower. So yes, thermal capacity of liquid 1 is less than liquid 2 because liquid 2 takes more time to gain heat and to lose it as well, so it has higher heat capacity. So the answer is D. Number 17. The metal surface of a kettle is hot. What happens to the cool air outside the kettle when it comes into contact with the hot kettle? Density of air decreases and the air falls. Density of air decreases and the air rises. Density increases and the air falls. Density increases and the air rises. The cool air outside the kettle comes into contact with the hot kettle, so of course the temperature will increase. And of course we know that warm air has less density than cool air. So when the density gets lower, the gas will rise. Air rises. So density decreases and the air rises, which is part B. Number 18. One type of double glazing consists of two panes of glass separated by a vacuum. Which method or methods of energy transfer is prevented by the vacuum? Actually, we have three methods of heat transfer, which are conduction, convection, and radiation. Only radiation depends on heat transfer by electromagnetic waves, which pass through vacuum. So vacuum will not affect it. Vacuum will affect only the other two: conduction, which is through solids and mainly metals, and convection, which is through fluids, liquids or gases. So the answer is A. 19. The diagram shows four waves drawn to the same scale. Which statement is correct? The amplitude of wave P is the same as the amplitude of wave R. This is correct. The amplitude of wave S is double the amplitude of Q, which is wrong because they are equal. This amplitude is equal to this amplitude. Both of them have an amplitude of 2. The wavelength of wave Q from here to here is double the wavelength of wave P, which is wrong since they are equal. 1, 2, 3, 4. 1, 2, 3, 4. The wavelength of wave S is the same as wavelength of wave Q. Wavelength here is from this point to this point, which is smaller than Q. So the only correct answer is A. Number 20. Light waves pass from air into glass and are refracted. What always remains constant when this happens? When they are refracted, they change the direction first. So instead of continuing like this, they will continue in a different direction. Change the speed since they are changing the medium, and change the wavelength, of course, but only frequency will remain the same. So the answer here is B. Number 21. Which type of electromagnetic waves is used in airport security scanners? It is D. X-rays. 22. Which waves are longitudinal? This is electromagnetic wave, so transverse. Light wave, which is also electromagnetic, transverse. And water waves on a pond, also transverse. Only sound wave is longitudinal, so also D. 22. An object is placed in front of converging lens. The lens has a focal length f. The lens produces a real enlarged image of the object in which labeled position is the object placed. If the image is real, so it will be at a distance greater than f, because less than f it will be virtual, so it's not D. And also it's not C, because at f it will be found at infinity. It's either A or B, but since it's enlarged, at A the image will be smaller than the object since the distance is greater than 2f. At B, the distance is between f and 2f, which will give us an enlarged image. So the answer is B. 24. A fire alarm is not loud enough and the pitch is too low. An engineer adjusts the alarm so that it produces a louder note and a higher pitch. So we increase the loudness and the pitch. What effect does this have on the amplitude and frequency on the sound waves that the alarm produces? Of course, if louder means the amplitude increases, higher pitch frequency is higher, so both of them become higher or larger, which means the answer is A. 25. In an experiment to measure the speed of sound, a student uses a stopwatch to find the time taken for a sound wave to travel from X to Y. She does this 6 times. The table shows her results. Which value of the timetable should be used to calculate the speed of sound? We'll take the average of these values, 0.5 plus 0.7 plus 0.6 plus 0.4 plus 0.9 plus 0.5 divided by their number, which is 1, 2, 3, 4, 5, 6. And the answer will be 0.6. C. 26. The ends of three metal rods are tested by holding and Q of rod 1 close to the others in turn. The results are as follows. And Q attracts and R and attracts and S, attracts also and T, and repels and U. Which of these rods are magnets? Since for rod 2, R and S are both attracted to the same end Q, so rod 2 cannot be a magnet. But rod 3 attracted from one side and repelled from the other side, so it's a magnet. And since it repels with Q, so also rod 1 is a magnet. So rod 1 and rod 3 only are magnets. The answer is C. Number 27. A permanent magnet is made from metal and an electromagnet uses a metal core. Which metal is suitable for these purposes? For permanent magnet, we need steel since iron is temporary magnet. For the core of electromagnet, we need actually a temporary magnet because we don't need it to keep its magnetism after switching off. For this reason, for permanent magnet we choose steel and for the core we choose iron. Part C. 28. Which law gives the unit of energy and the unit of electromotive force? Unit of energy is joules, like the unit of work. Unit of electromotive force is volts, like the unit of voltage. So the answer is B. 29. A student carries out an experiment to investigate the resistance of a resistance R. She takes a series of readings of potential difference and current and plots a graph of her results. Which circuit should she use? Measuring voltage and current means that voltmeter for voltage for potential difference should be in parallel and ammeter for current should be in series. But in this case, the voltmeter is connected in parallel but to the battery, which is wrong. We want to find the resistor R. So V should be, the voltmeter should be parallel with the resistor and the ammeter should be in series with it. In part A, voltmeter is in parallel with it, ammeter is in series, which is correct. In C, it's wrong since the voltmeter is in series. In D, it's wrong since the voltmeter is in parallel but with a variable resistor, not with R. Same as B, voltmeter is connected with the battery, so also rejected, only A. Number 30. The diagram shows a circuit with 3 ohm resistor and 2 ohm resistor connected in parallel. The switch is open and the ammeter reads 2 amperes. The switch is now closed and the ammeter reads total current of both resistors. What's the ammeter reading when the switch is closed? When it was open, the ammeter was reading 2 amperes. 2 amperes actually multiplied by 3 ohms is equal to 6 volts. Now, when the switch is closed, current is passing from here and from here as well. Also, voltage of this resistor is equal to 6 volts since it's in parallel with the battery. So, V is equal to IR, which means that I is equal to V divided by R equals 6 volts divided by 2 ohms is equal to 3 amperes. So 3 amperes in this branch and 2 amperes in this branch. Ammeter A will read 3 amperes plus 2 amperes, which is equal to 5 amperes. D. 31. The diagram shows a torch containing two cells, a switch, and a lamp. Which is the circuit diagram of the torch? We have a battery connected with two cells in series, positive of the first one to the negative of the second one, and a switch. This case corresponds to A, because in B, negative is connected to negative, which is not the case. In C, they are in parallel, but here they are in series. And in D, also the batteries are in parallel, which is not the case. So the answer is A. 32. 32. An engineer uses the potential divider shown in the diagram. He needs an output voltage to be 1/10 of the input voltage. So if I have here, for example, V1, I will have here V1 over 10. And of course here I will be having V1 minus V1 over 10. This is V1 over 1, which is equal 9 V1 over 10. 1/10 of it over here, and 9/10 over here, 9 over 10, so that the sum will be 10 over 10, which is 1 V1. Which pair of values can be used for the resistor X and Y? Because here I have 1 over 10 and here I have 9 over 10, so the resistance at X should be 9 times of Y. So in each case I can divide X over Y. The answer should be 9. Here 1 over 9, which is wrong. B 1 over 10, which is also wrong. C 9, which is correct. D 10, which is wrong. So I put 9 ohms at X and 1 ohm at Y. This will take 9 over 10 of the voltage, and this will take, Y will take 1 over 10 of the voltage. And so the answer is C. 33. The current in a kettle is 10 amperes and protected by 13 amperes fuse. The owner of the kettle replaces the 13 amperes fuse with a 3 amperes fuse. What happens when the kettle is switched on? The kettle needs actually 10 amperes to work, and the fuse will burn at 3 amperes. So of course the fuse blows, but nothing happens to the kettle because it didn't reach its normal current. So the answer is B. We cannot say that it does not blow. Yes, it does blow. The fuse blows, but the kettle is undamaged. 34. The diagram shows cables used in transmission of electrical energy. High voltages are used for the transmission. Why are high voltages used for the transmission of electrical energy? We know that in transmission lines our aim is to reduce the energy loss and power loss. Power loss actually in transmission lines is equal to I squared multiplied by R. R is the resistance of the wire, which we cannot change. So we have to work on I. We know that P delivered or supplied is equal to V multiplied by I. P supplied is constant actually. So in order to reduce the power loss, we need to reduce the current. Reducing the current will be done by increasing the voltage, since they are inversely proportional. V and I are inversely proportional since their product is constant. So increasing the voltage will reduce the current, and so the power loss will B less. A. Fear of high voltages stops people interfering with cables. This is wrong. B. Heat loss in cables is smaller than if low voltages. Yes, if high voltages, when voltage is high, the heat loss is smaller than when the voltage is low. Right, so it is B. 35. Which diagram shows the magnetic field pattern around a wire that is carrying a current perpendicular to the page? When the current is perpendicular to the page, this means that the magnetic field is circulating around it. So it's either A or B. But we know that the current is stronger as we approach the wire. That's why the circles closer to the center, to the wire, should be close to each other, and as we move away, the distance between them gets bigger. That's why the correct answer is in B, since the circles are closer to each other, which means high magnetic field, and when we move away from the wire, the magnetic field strength gets lower. Unlike in A. In A means that it's weak next to the wire, and it gets stronger as we move away, which is wrong. 36. The diagram shows a simple transformer with input of 240 volts and an output of 40 volts. There are 600 turns at the primary. How many turns are there at the secondary? We know that voltage at the primary divided by the number of turns at primary is equal voltage at the secondary divided by the number of turns of secondary, which means that 240 divided by 600 is equal 40 divided by n secondary. Cross multiplication, 240 n secondary is equal 40 multiplied by 600. N secondary is equal 40 multiplied by 600 divided by 240. The answer equal 100. A. 37. In a cathode ray tube, a hot tungsten cathode releases particles by thermionic emission. What are these particles? Thermionic emission is by definition the emission of electrons at high temperature. B. The diagram shows a radioactive source, a thick aluminum sheet, and a radiation detector. The radiation detector shows a reading greater than background radiation. What type of radiation is being emitted by the source and detected by the detector? We know that radiations are alpha, beta, and gamma radiations. Alpha and beta are blocked by thick aluminum sheet. Only gamma can penetrate through them. So the answer is C. 39. The count rate from radioactive isotope is recorded every hour. The count rate is corrected for background radiation. The table shows the readings. What estimate of the half-life of the isotope can be obtained from the readings in the table? If we start with 800, after one half-life it becomes 400. After the other half-life it becomes 200. And from the table, after 5 hours it became 220, which is almost 2 half-lives. It's actually less than 2 half-lives, since it didn't reach 200, it reached only to 120. So if two half-lives are 5 hours, so each half-life is 5 over 2, which means 2.5 hours and a bit more. So the answer is between 2 and 3 hours, close to 2.5. And so the answer is B. Finally, number 40. A nuclide is represented by symbol X, P, and Q. How many neutrons are in one nucleus? Q represents the number of protons and electrons. P represents the number of nucleons. So the number of neutrons is the number of nucleons, which is P, minus number of protons, which is Q. So P minus Q. D. Thank you.